So if you haven't started Dynamo inside of Revit, you'll want to click on create a new empty project. And I think we should probably start with a project for this exercise, but we are going to be making a family a bit later. Everyone knows the difference between a project and a family. Okay, great. Okay, for those who don't, so a project tends to be, again, that left-hand side here, the kind of macro collection of components, and you have one project for a building, typically. And then the actual, say, say a window component or even a mullion detail, those could be individual families. So there could be a family inside of a family. Projects have things like locations, and whereas a family wouldn't. So that's like one example of the differences.
What template should we be using?
Okay, the architecture is fine. So again, just click on Dynamo.
You can see this one, all right? Kind of.
There you go. That works. You might want to full screen it.
I can't.
Okay, whatever. Okay. So to begin, I'm just going to double click, and I think Colin went into this a bit last time, and I'm going to make a code block node because it's a way of sort of quickly getting out some base geometry pretty quickly. So I'm going to make a few point-by coordinates, and hopefully autocomplete is working so it shouldn't be too hard. So I'm just going to lay out some points here, making one at 0, 0, making one at 4. I'll add actually a variable in here right now with 20.5 coordinates, 8, 0, 12, negative width,
Autocomplete's nice.
it is.
Might want to leave that up there for a little bit.
I will, yeah. So and note that I have the curly braces and the beginning and end of this, which is indicating that this is automatically going to make a list. If I click outside of here, we'll notice that it's extracted out with. So it understands that there's a missing variable there that we're going to probably want to fill in with something. So the specific numbers don't necessarily matter that much, but I kind of just want to reiterate some. These are some of the core features of the language that you're going to want to get up to this speed.
Yeah, that's what I was afraid of.
So I'll just make a double slider. Again, this isn't super important, but it'll help us kind of flex our model a bit later.
Give me a second here. I'm trying to see if I can get it bigger. Yeah, sorry guys. I say request your departments to get LCD screens.
But so here what we can see is we're kind of making a set of points here that as I move the slider around, they kind of, these points in the middle move a bit.
There we go.
All right, so with these points, we're then going to make a NURBS curve. And you'll see, if I just type in NURB in the search term, and just a quick way to get up there is if you hit just escape and start typing, it usually will bring up the node that you want given the input search string. So here we have several 5 points, and if we hover over them, there's going to be a tooltip that's going to explain the various functions that we can use to create a NURBS curve. So here we have one with just points. Here we have one that indicates whether or not we want to close it or not, or we can also just specify the degree.
We're doing this curve.
Yeah, this NURBS curve by points. Okay, and then up here, I'm going to make 2 more points by coordinates. one at 0, 0, and then 15. And note that I don't have a curly brace, I'm just putting a semicolon. And then we also want to do 0.5 coordinates at 16, 0, and then 15.
Can you zoom in on your notes a little bit?
Yes.
Yeah.
There you go.
Question, do you, does it matter if you have spaces in between that 0 and 0, 15? Like,
Yeah.
is it just programming
Yeah.
stuff? Yeah.
Similar to many programming languages, the actual white space doesn't matter at all. I can actually, well, last semicolon might be a problem. But yeah, I can do this as well, and it'll just simply reflow. You can also, if Colin didn't cover this as well, you can also do a double / comment, slash to indicate a comment. So this is a line at start point. So these are things that you really just want to format your code so that it's readable and that someone in the future who might be looking at it or another team member would understand what's going on.
Right.
These are pretty straightforward and simple, but you know, as you get more complex scripts, it matters. Now we'll make a line as well by start point. Finally, we're going to make a list for these two curves. So if you do list dot create, it should come up.
How do you make it more than one code? This matter.
So everyone has two curves here? Okay.
So this list create, is it basically just allowing you to combine them? So if you want to do something in the future, it will have this.
Yeah, that's a good question. So we can note that, so what we really want to do here is create a surface by lofting. But we can note that, and this is going to be very similar to an example Colin showed, but I want to make sure everyone sort of has the basics of Dynamo down. But we can see that if we hover over a surface by loft, we can see it takes a curve, square bracket, open square bracket, close square bracket, which indicates, if we zoom in, this just indicates, well, that text won't get bigger, but it's indicating that it's going to take a list of curves. And so that's why we have to build a list here.
So can you explain the difference between having cross sections or cross sections and side curve?
Sure. The question is, what's the difference between lofting between curves and lofting between curves with a guide curve? In this particular case, it would matter. Well, so imagine if we draw a diagram.
Yeah, that's, here, tell you what, while keep going,
Yeah.
I'll draw the difference there. Okay. Because we have to turn on the board, it has to be up. There's no like whiteboard where you can just draw.
They don't have extra markers.
No.
Okay. Yes.
Can you zoom the notes a little bit?
Sure. Are these ones here or?
The line was, okay. Yeah. Thanks.
Whoa. Oh, I see. So you're going to
So everyone's kind of made it to this point here. So the final thing I did was once I created that list of curves, I'm now doing a surface by loft. And actually one more question I was going to ask you, who here has experience with Rhino or Grasshopper? So a few people, okay. But
This is the difference. The guide curve gives you an extra degree of control where you can actually tell it what vector to use. Here it's just defaulting to the shortest distance of the 0 parameter of each. So this is your parameterized curve from 0 to 1. I believe, and Patrick can say if not, but it's giving you the shortest distance. It defaults to the shortest distance to connect the 0 points. With the guide curve, which is here, you can actually get a different interpolation between them.
right.
A lot of work for a whiteboard.
Now you can save it without even emailing.
Exactly. Want to keep that for the rest of the month? Yeah, I'll email that to the class.
So the guide curve, not the service by law, just a different one of those. Is that what with the extra guide, okay. So when you see brackets, you need to have it a list first.
Exactly, yeah. And that's going to pop up either on the input here. So the start point expects just a single point. Of course, you can replicate across this, as Colin was showing last time, but we won't go into that here. But yeah, just that's the difference between just having a point pop up and curve the bracket. Okay. So at this point, this is the kind of free-form geometry that would be something that would be relatively difficult to do in Revit as this geometry gets more complex. So that's why we're essentially starting with it here. Right now, we're just going to start with how we can place a single sort of window detail on this surface, and then later we're going to show how we can apply it to the entire surface. But so in order to kind of place this on the surface, we'll need to get the points on the surface. So we can say point at parameter. And I think what Colin showed last time was, so this should be kind of just a refresher. We can create a code block node very quickly. I'll zoom in a bit here, but we can go, we know that the parameter space of all the surfaces, curves, and solid faces on all geometry and design script goes from 0 to 1, which isn't necessarily true in other applications, but it is true in Dynamo. Meaning that at position 0, 0, that's going to be one of the corners of your curve, and then 1, 1 is going to be the other, or the other corner of your surface. And indicating this hashtag here indicates we want 10 elements. So again, this is a refresher. You guys went over it last week. So I'll go somewhat quick.
The hashtag is always defining an integer.
The hashtag is it will be rounded to an integer, but it's indicative of the number of elements in the collection, which by definition has to be an integer. So here I've plugged in 0 to 1 hashtag 10 or pound sign, and then I changed the lacing cross product, and this is generating a whole series of parameters on this surface. So the last thing we need to do is actually extract out the individual points here. So to do that, I'll make a code block node one more time. And to the people who actually have some background in Python or other scripting language, this should be fairly straightforward. But for those of you who don't, the way you sort of access sub-elements of a collection in most programming languages is with the square bracket syntax. So here I'm just making up essentially a dummy variable here. I can call it perhaps points. And then in the square brackets, I'm going to notate what element I want to grab out of this two-dimensional list. Because actually, if we expand out this, we can see that it says we have a list of 10 lists, and each list contains 10 elements. So here I'm going to do square brackets, say 3 and 3. And this is actually going to then grab the fourth element down. So here I have 1, 2, 3, 4, because remember, as Colin was saying last week, most programming languages are 0 indexed. So 0 is going to give you the top element, or so the far right-hand side element here, whereas 9 is going to give you the one on the other side. So here I'm just going to grab 3, 3 cutover points, which is giving me
Hey, Patrick, is this a good time to play catch up? Is it the,
right, yeah.
Is there a way to change the origin point to
Change the origin point of the UV coordinates. What do you mean by that?
So like right now, if you say 3.00, then it starts all these specific orders.
So this is literally just fine.
0, 0, 0.
It sort of. On a curve, it's a bit easier. You can actually flip the direction of it.
Yeah.
So similarly,
How do I?
clear it.
If you want to do colors, you don't have to say that. You have to work.
So if we just make a very simple curve here, the question was about parameterization. We know that the start is going to be 0 and the end is going to be 1. If we call flip, it's going to do the exact same thing but make 0 and 1. Unfortunately, on surfaces, it's actually a bit more complex because what will happen is 0, 0, and 1, 1. Usually what will happen is it'll just invert it to 1, 1. This will go to 0, 0. So if you want to explicitly move this over to that corner, you might simply have to rebuild the geometry from begin with. So yeah, it'll flip the whole thing at once. You might just want to play around with this. I think what you might alternatively do is then once you have all the points out, you can just sort of transpose the actual lists themselves, either with the Dynamo code or say code block node or Python for the list management tools. So I'm going to actually close this down because it looks like I think Dynamo has gone into a weird state on my computer. I'm running kind of the development build, but let's.
Oh, you can just copy.
Yeah, so I'm going to copy and paste this 4 times because I want to get the 4. I want to get 4 points onto which I'm going to attach a sort of window component or kind of pattern component. So here I'm just going to change the elements of this code block, going from 3, 3 to 4, 3 to 3, 4 and 4, 4. Okay, and I'm going to pretty much stop here. So is everyone, I just want to make sure everyone's caught up at this point.
Could you help us debug over here, Patrick?
Sure.
Let's see what red options are.
So we want to trigger releasing. If you
It's on a cross product. It's on.
Usually in these situations, I would save Dynamo, and then like as a temp file, and then just close Dynamo and restart it and see if that happens. Are you, actually, sorry, that actually can just be anything, it's certified by law.
Oh, we're gonna go
On a parameter. And in fact, you probably want to disable cross-reference. Which is a lot. That might,
So students use cross-product.
I don't, yeah, so if you're doing the cross-product on.
I wonder, so student cross-product, no. Well, anyway, I'm not sure. Sorry, we're doing cross-product.
Okay.
When you guys are in a group, like you work in a group, how do you do this? Like, how do you work together?
How do you divide this job? We have three or six.
I can respond to that.
Okay, yeah.
So you've got, first of all, you have to come up with two different schemes. A planarized panels, right? And you've got to come up with the curved panels. So you could have somebody working on the node or the object. So again, you could build the object in, this is the panel itself. You could build that in Revit, if somebody's capable in Revit, or you could build it as a node in Dynamo. So you could have somebody working on your curved panel node or your curved panel object. Then you can have somebody work on your flat panel object or your flat panel node. And then you have someone working on your panelization boundaries, your layout, right? The surfacing information. So that's 3 jobs right there.
Yeah, and so we'll jump into Revit and start making a family. That'll begin, because at the end of the day, you are probably more concerned with your BIM model or your BIM file.
Actually, we told them they don't have to use, I mean, they can come up with a panel however they want. If they're
Okay.
comfortable in Revit, they totally can. If they want to stay in the Dynamo workspace, they can.
But yeah, one thing that comes to mind is, again, if let's say you had one person who's really good at Revit, one person who might be good at Dynamo, another person who might have some Python background or kind of coding background, that would be a great way to split it up in my mind. Where one person is managing the actual BIM material information and managing the families. Another person is actually writing, say, the list management code, some of the new algorithms to generate form, and then another person is stitching those together with Dynamo and managing the workflow. You need
So you got 3 ways to organize. One is by trade, which is what are you best at? And the other is by task of what do you have to do. So
Anyway, there's many ways to do it.
this isn't a management theory course, but I think you guys will figure it out.
Well said. Okay, so if everyone's caught up here, the next thing we probably want to figure out is what order these points are in. So as I click through here, I notice it's kind of following a kind of Z pattern. It's going from up here on the upper right. Try to zoom in a bit more. Here, why don't I'll hide my. So it's going from the upper right over to that side, and then kind of going back into this Z pattern. So I just want to reorder my points here so that I have a kind of consistent clockwise ordering of these points. This isn't necessarily required, but to me, that's more intuitive. Just think of this as going in a circle versus a kind of Z pattern. But it won't matter as long as you're consistent with what you're doing in Revit. Okay, so this is sort of where we can pause a bit in Dynamo. I'll just save this again with home. All right. Any questions, or is everyone sort of up to speed here? Okay.
I don't see any colors on their graphs. So.
Okay. Oh, you don't see any yellow. Okay. Yeah, that's great. Okay. So now I'm going to move over to Revit, And so here again, we have an empty project. Okay, we can check the 3D view, nothing's in here. But so now we're going to switch over into the kind of what Revit does well, which are these, again, family elements with information about material and using stock components that you need to populate your model with when you're actually going to make a building. So to do that, I'm going to make a new family. And so this I guess, is also recap because you guys have some Revit familiarity. What we want to do here is make.
Who in here does not have Revit familiarity?
Okay, you guys. Okay. This should be fine because do you have Grasshopper background or any 3D modeling? No. Okay. Or some. SolidWorks. Okay. Oh,
These guys are from the product design.
Okay. Yeah. You have 3D modeling experience, so it'll be intuitive enough. So as we. Okay, so we'll just go up to new, and then in this kind of breakout we have family. Up to now, if you've done like a Revit intro class, you probably worked with projects or conceptual math. What we want to do here, though, is the interaction with Dynamo works best with something called an adaptive component. And I have a list of links that I'm going to, because I know we're probably going to go over in time anyway, but I have a list of links where you can learn more about adaptive components. But they're slightly different than every other Revit family. So as just feeling, this will be recapped for some people here, but oftentimes you can sort of reconfigure most families to adapt new patterns or update the information if you decide this being you made wants to become a column. In other families in Revit, you actually do need to explicitly say this is going to be of a certain type, and you can't go back and change this. Adaptive components are one of those. So you need to make sure you make an adaptive family here, and the way you do that is selecting generic model adaptive. So we're going to open that up here. It should be in the stock kind of template family file. If it's not, you might need to reinstall Revit. But let's just open that up here. And
So
while
you
we're
will not have the adaptive component of the family? Okay.
and just one thing to note, it says generic model here. This doesn't matter too much in your project, but just note that this isn't set. All we're really setting initially when we open up the adaptive file is the fact that this is going to have some kind of reaction. The geometry that you specify to create the family is going to have an impact on the internal form of the geometry. But it doesn't actually specify the category. So here we can actually change it to, if we want this to be a current panel, or maybe you want to have an adaptive component in the door, you can change that in the family category and parameters. So this doesn't really matter. It will help when you're trying to track down this family in a larger list of families when it's in your project, but isn't crucial. But so here we are. Okay. So we'll just start out with a very simple adaptive component here. And I'll start by clicking, so for the people who aren't familiar with Revit too much, you typically always have a set of base planes or work planes that you set. This one you should be set with this stock kind of XY work plane, but if not, you simply click on one of these work planes here and just hit set. And that means from now on, whenever we're making geometry, it's going to default, when I sort of click into model space, it'll map onto that base plane. So we're going to make just a very simple line here, or rather kind of set of connected lines. And I think I'll just go back and reiterate how, like before, when we were making form, we had to explicitly say, like, I have this point here, and I have this point here, and this point here. One of the nice things about working in Revit is, of course, you can just click into model space and create things that way. So I'm going to create a line here, and then make sure I have 3D snapping checked. So there's this under draw and under modify or create, we have this little line here, and then down we're going to have 3D snapping. So I'll click. So now I actually just want to click 4 times, really anywhere. And when I'm done, when I made it a kind of square form, I'll just hit escape. And in order to make this an adaptive component, I'm going to select all of these points. And this is what's actually unique about this family type, is that I now have, once I've selected several points, I actually have make adaptive popping up here. So if I click this, let's see what happens. Oh, yes.
How do you do after you finish the square with line?
Yeah.
The next step?
You'll hit escape. That's kind of a Revitism where
No, yeah, but like how do you make the points like that? I did escape, so I finished the square.
you might not have had, without looking at your screen, you might not have had the 3D selected. So if I do create here, do line, if I don't have 3D snapping selected, what you do?
He's trying to just select the points, is that?
Oh, select the points. Oh, well, I just went around, well, there's two ways. You can either kind of grab all these, and then if you hold down Shift, and then you have to kind of, you can deselect all the stuff you don't want, or you just go around and click on one. I guess I can make another one here, like, and then escape out. You click on one, hold down Control, and then the cursor will change to a plus sign, and I'll click on the other guy, and just go around. Okay, so is everyone? Okay. Do you have more of these? I've never seen this before. I can make a stupid suggestion of trying it again.
Oh, but
It's that bottom.
Oh. Really? Even if you
Yeah, I don't like the bottom part where it's like really snapped.
There we go. Just crossing window, I guess, is the best way to say it.
Well, you don't. I'm not seeing this. You'll need to make sure. But if, for instance, if I don't have 3D snapping on, it'll do exactly what you had. So it'll just be a line. That'll be kind of dead. I'm not seeing that this kind of title is popping up.
Right, that's the, oh, this on the very bottom, I got it. Okay.
Okay. So next, now that I have this closed form, and again, notice how these points are going in counterclockwise order. That matches up with the order that we previously defined in our Dynamo graph. So again, if you wanted to have that zigzag pattern, you could. You just would want to make sure that when you were initially clicking those points, you want to make them in the like 1, 2, 3, 4. This 1, 2. But anyway, now I'm going to select this closed loop and hit create form. And Revit is going to ask, do we want to make it a kind of solid type form or a flat one? So we're going to make it a solid form. This is our really basic window. All right, but before we exit out of here, I just want to edit the properties of this family. So does everyone here know about family properties?
You're going to go to material stuff?
No. Well, Probably, I don't think we'll have the materials, but I think, we will do kind of modifying the properties of the object. So I just clicked on that closed kind of line, and then hit the make form button. And now I'm clicking on the properties, which is under modify form element in this upper corner, and I'm going to add a new parameter. And I'll add something called, say, window thickness.
Oh, yes.
So, yeah, just to make sure everyone's on the same page here. I went into family types, which is this kind of, it's in properties and it has these kind of 4 boxes next to each other. And then I'm adding a new parameter, hitting add. So anyone who has some sort of programming experience, this is basically a variable. Or in SolidWorks or CATIA, it's kind of like, I think they have like formula or a similar idea. It's like a label for a number that you can change, but use that number many times in your family. So I'm clicking on add. The only thing to really note here is it's going to be a family parameter, and it's going to be of type instance. And I'm going to name this just window thickness. I'll make it 1 foot. Apply. Hit OK.
Bulletproof.
Sorry.
Bulletproof box.
Yeah, right. Oh yeah, I made it 1 foot, of course. Yeah. Whatever. Okay. So I can change that later. So the next step though is we can see when we click on this form here, it has a positive offset constraint, and on the far right side there's this kind of narrow gray box here, and this is what's going to allow you to drop in that variable into that number value. So here we have window thickness, which we previously defined. And if I do this, it's now going to be the 1 foot base class. So you're totally right, and just sort of indicate that this is kind of truly parametric. If I actually update this to 0 and maybe a more reasonable, maybe 1 inch would be, or even 3/4 of an inch would be more appropriate. If I hit apply, the thickness goes way down.
This is there.
And while I'm not going to go into it, this is what Jordan was mentioning previously. If we wanted to have this define the material, if we wanted to have it, which would determine the UV value, if we wanted to determine a profile of a kind of sweep curve, we can do that as well, but we won't go into that quite yet. So I'll save this and just save it as perhaps window. The window family. So is everyone sort of up to speed here? Are you good?
No. So I noticed that you have multiple images. I've only seen this one.
Are you clicking on the form? So you might need to tab around. So actually here I have a bunch of kind of extra stuff. It says chain of walls or lines. I'm actually now tapping, and now I have a form element surface. And that's when I'll get this. So that might have been one of your issues. Because if it is this actual form, then I should.
Get all of this.
Yeah.
Okay, now this is all right, so this is what we'll do. Now, first of all, who needs to leave at 11:50? Okay. Charge through it.
Okay.
If they fall behind, they do, but we're recording it so you guys can catch up later. But he needs to get through the instantiation process here, so
Okay.
charge through.
So now we do have this open project from before. It's pretty much empty. But now I'm going to take this family that I just made and click Load into Project. And Revit is pretty nice in letting you sort of easily determine whether or not your form is working, because now we actually have a prompt to start clicking on points. And remember how we defined 4 points before? Okay. Now it's prompting me for 1, 2, 3, and 4. And I can do that again. And I would, you essentially will want to do this just to sort of make sure that you set everything up correctly. But if I look in here, I now have this kind of 3/4 inch window. I can see window thickness is 3/4 of an inch. It has these 1, 2, 3, 4 points. Everything seems to be working. But more importantly, actually, what we have here is, remember when I told you how I changed the family type? Under current systems, or maybe I didn't change it. Oh, there we are. Under current panels, I now have this window here. So it's been loaded into my family, and now we can start accessing it in Dynamo.
Is it automatically saved? Or do you have to save it?
You'll want to save your family, yeah. And that name is going to be specified here. So here I named it window, and I gave it the category previously of current panel, and that's now put in here.
And it says place on face as opposed to place on work plane. Like,
Keep going, Patrick.
yeah.
Okay, no, it's okay. Yeah, I think you haven't quite set up your points quite correctly. That would be my best guess.
The order in which you select the points is important when you're creating that element.
Okay, so we're now going to now that we've loaded this family into our project, we can actually now access it in Dynamo through the family types node. So under Revit, there's kind of a bunch of elements. I just searched for family. Family, if you type FAMI, it's going to pop up here, family types. If we scroll down, I have, by the way, window is a terrible name for a family, but whatever. It'll work for this. Name your stuff more descriptive, but yeah. Yeah. All right. So, and the second thing we want to do now here is we can instantiate this adaptive component. So similarly, I'll just search for adaptive component. Oh, here we are. And now we can see in Revit, we have Revit elements, adaptive component by points. So it's actually fairly straightforward. We have a set of points, and they're organized in this counterclockwise order, just like we have in our adaptive component. We have the actual name of the adaptive component here, and we have this node that's going to take those points and yeah, instantiate it. So here I'll just make a quick list. I'll create points.
So you're creating the list first and plugging the list into the adaptive component.
Yep. So after I run this, we can actually see in model space we now have our adaptive component here. Okay. So
Now, the difference here of visualizing in Revit versus Dynamo, can you kind of get the high level here?
oh, the difference between
Meaning you just ran on Dynamo. Before we've been working in the Dynamo environment and visualizing geometry in Dynamo. You just visualize the geometry in Revit.
right, yeah. So for instance, this this surface here that we created that I unpreviewed. Oh no, these are the points, but this doesn't exist in Revit, and for good reason. This is a surface of no thickness, so it couldn't actually exist. Whereas everything in Revit has usually it's of a type like a wall or a window, and it has category information. So the typical workflows that we've seen people use is Dynamo is used to make the scaffolding from a higher level perspective, in sort of like that rendering perspective on the side, and then you're sampling that geometry and instantiating real-world objects on top of that, rather than just being forced to use Revit for the high-level stuff as well. Okay, so now I'm actually going to introduce, let's see, quad points on face. That's the thing we need. So Colin briefly touched on this last week, but there's a package manager inside of Dynamo that allows you to search for code that has been written by external developers that just makes your life easier. Oh, question?
I get an error
When you try and instantiate it?
when I'm trying to match my family file to the adaptive component.
Keep going, Patrick.
Okay.
Guys, we'll troubleshoot. If you're independently having problems, we'll troubleshoot later. You can watch the video, but he needs to get through this to show you guys how to instantiate these components on that surface.
Yeah, so essentially right now, the issue is we now have a whole set of points. We want to get groups of 4 points that are going to be useful for, like, we essentially, for each one of these points here, or each set of 4 points, we want to get a cluster, like an individual list of 4 points that is also in counterclockwise order that we can then use to instantiate each one of these windows. And someone's made a very useful tool for this. It's in the package manager. So again, you want to go into packages and search for packages, and it's just called quad points on face. So I'm actually just going to install this now. Quad points on face, which essentially just takes a surface that we have here. If we want to get 10 elements here and 10 elements in the V count. And now we have a whole set of lists of these kind of grouped quad points. So if I push this into here, my adaptive component, and hit run, you can see that I've actually instantiated this window. And I'm using that term loosely, but in the future, your adaptive components should have this, or could potentially, and I would encourage you to have that same level of detail as Jordan was showing earlier. But now we've essentially instantiated each one of these families, or family types, onto this surface. But if I double click on this, it's still going to break back into this window editor. And so if I essentially make a change here, like draw a line and save it and load it back into the project. Oops. Override is. Oh no.
Oh, we blew that one up.
Okay. Okay. Yeah. Imagine that worked. But the last thing I want to show is, remember how before we were able to modify, or we set up the kind of window thickness. One of the other things you can do is some of the elements in your family types or your adaptive components can be determined purely geometrically. So these are the corner points of the windows, for instance. But other things like material or even thickness might not be able to be determined purely geometrically, and that's why we set out the window thickness property. So I'll just search for, we're going to want to now update the element property.
All right, y'all, I have to leave to go pick up our speaker for tonight, but listen to Patrick, he's smart, and Forrest will follow up with potentially having another workshop. So I'll see you guys tonight, and if not, I'll see you Wednesday. Okay. Somebody just do the Frank Underwood knock?
I'm actually now I've gotten with his noted name with that sign, so, yeah. Set parameter by name. Okay. Set parameter by name. So for each one of these elements, we already determined that our parameter name was, I think, window thickness. So I'll create a new string here, window thickness. Just an encode block node. This is similar to the syntax in other programming languages, just open double quotes, window thickness, close paren, or close semicolon, and plug it in here, and then assign it a new value. So maybe we want to make it, well, actually, so one thing to note here briefly, all of the numbers in Dynamo are decimal meters, but we actually previously had defined the value to be in inches. So I'll choose something fairly small here, but this is more to illustrate that we can just update the actual family property through Dynamo. So I'll probably set it to a slider. Perhaps a maximum of 1. Here. So I'll rerun this. We have all our elements here, and if I can open this up in Windows, run automatically. Should be able to increase the thickness. Okay, so there we go. I think for some reason run automatically wasn't working. But again, if I change this here, it's going to get super thick. I might have to rerun it manually. But these are the kind of core workflows for how you can model a fairly detailed design with Revit families and kind of stock rolling details and other details you might have, and then instantiate them on the geometry you create in Dynamo. There's other stuff I can cover now. I think I just perhaps want to step back and say, like, are there any other questions about what we're doing here or topics you want to go into? Otherwise, I think the agenda was potentially importing information from Excel using Python nodes or code block nodes or C# nodes. So those are things that, again, if people have kind of a computer science and programming background, they might be able to stretch their Dynamo work farther. So any other questions?
When you were looking up Dynamo family type and adaptive,
The adaptive component by points.
those didn't show up on that search.
Adaptive component by points did not. Are you running it inside of Revit?
I had that problem too. If you just open the Dynamo by itself, then it won't show up.
Oh, I run it inside.
Oh yeah, sorry. Everything that's sort of Revit related will only appear. They aren't loaded if you're not running in the Revit context because they. So in other words, you have to start up Revit first and then click that add-in button to start up Dynamo inside of Revit. But yeah, as a standalone application, you can make the geometry, but then yeah, the workflow.
So there's on the forums section, there's like installation instructions. It's free for students. There's, I think, also Since we're running short on time, I think that we'd like to do another workshop out of class time. So we're going to poll to try to figure out a good time for everyone. Is generally evenings, I think, maybe the best time, given people's schedule, unless there's another suggestion for time. Are you thinking?
That's engineering and economy class, Wednesdays 16 to 7:30
On
on Monday and Wednesdays.
Okay, so it doesn't necessarily have to be Monday and Wednesday, but I'm thinking, I don't know, maybe around 6 or something, that can work for most people. Okay, so I'm just going to do like a Monday through Friday thing at around 6 p.m. and then we can get just an idea of where the best time. If we get 8 or more in one time, then we'll just schedule it at that time. And then since we have, I think there's 21 here, in terms of teams, anyone still looking for a team? We straightened all that out? You joined us? Okay, so I think we've got everybody teamed up? Okay.
No, sorry, we have 2 of us in the team, we need 1 person to make 3.
Okay, so I think there's 21 here, right? So somebody,
I'm out of the class.
oh, okay. Okay, perfect, all right. Okay, so we may end up with an odd number, in which case, I guess we'll just have a team of 2, and we can address that workload a little bit accordingly. So, yeah, maybe we can just do like a flat panel speed. Yeah. Any other administrative concerns with Sherpa?
This is more than a question. You mentioned there are a lot of other capabilities. Do they have good resources? Or maybe we already have that.
Sure. Well, I mean, if Colin didn't show you this last week, dynamobim.org. It was a great portal. So there's a Learn tab that has a lot of videos. I can also send out a follow-up email with more information on adaptive components. I do have one good resource for how to make Revit families of a level of detail that you might want to be working for what you're doing here. It requires a Lynda login. I don't know if students here have.
Which one?
Lynda.com.
That's also interesting to have. Yeah.
Awesome. Yeah. So I think if you just want to learn more about making like a window family, that would be a great resource. So I can send out that link.
Cool. Yeah, so you guys, probably some of you have already found it, but all of the sort of links and help topics around Dynamo or around any of the other topics are going to be in the forum section of coursework. So you can go there for blogs and links and help topics. So yeah, thanks very much for
no problem.
the presentation today. So. Yeah.
I have general questions regarding assignment and brief. I
Yeah.
think everybody has questions. So,
Okay.
use topography, because the first input for design is outside, how we design views and regarding.
Yeah, so Steve, have you done the Google Earth workflow?
Yeah, I posted one method where you could evaluate your models and get all the renderings you need from Google Earth.
I think that's going to be the way that we're going to go. So you can bring your model into Google Earth, and that way you can get the context. And is that it?
Does anybody know the quick way though to bring maybe Google Earth or some other landscape topography into Revit? Is that?
For very thoroughly, you just like the coordinates or the address of the place that you're theoretically building it, and then this is how you should do the option of actually making topography free.
Yeah, I don't know. There's no buildings, right? Like that's the thing that's really important for London is the built topography. No easy way to do that. If somebody does, though, I'm happy to flesh that out too. But right now, we're just taking it, put it in Google Earth for that kind of evaluation. And that's in the forum, so hopefully you guys will be able to follow that.
We're just have no idea what the discussion is about. Like,
Oh, it's just about having the context for the reference surface. So you guys have the surface, but you want to put that on the site with all the adjacent buildings
and just to see what it looks like.
just to see what it looks like and get a perspective of scale of the building relative to the surrounding site and that sort of thing.
Furthermore, product has requirements, but we do not have metrics for durability except saying it has to be 30 years design life. How do you know it's 30 years design life? It's not tested or some specific parameters. I mean, it gave us a general type of requirements that basically we can't parametrically design any except general geometry because of transportation. So you know what's the largest and the smallest, for example.
Yeah.
But everything else is descriptive. So should we also go into
Well,
design descriptive?
So that's a good point. So we're not expecting you to do simulation-based analysis of things like structure and energy, but there's geometric related things that have to do with the credibility of the structure, right? So like for structure, you want it to have a clear load path, so it has to be able to address horizontal loads and vertical loads. And so in your presentation, we want you to be able to intelligently discuss and say, okay, this is the mechanism by which it resists horizontal wind loads. And you don't have to analyze it, you just have to have an explanation of how that system would work.
So dimensions of a panel,
Yeah.
should we do like according to our experience? I mean, I have experience, but the question is for others who do not have experience in designing facade segments.
Yeah.
So we just design according to our, let's say, knowledge, or we will give some examples, yes, of curtain wall.
Yeah, so the lectures will continue to go through examples of curtain wall. We'll talk about high-rise design on Wednesday. And then we're going to give you some readings that are going to talk kind of more detailed of what Jordan went through with all the performance descriptions. So, yeah, right now it's just those readings and a knowledge of what the maximum transportation volume is. And so that's all we're expecting.
We were just afraid, it's so everything general, nothing specific. So how do we design even parametric design requirements of the event? That was our question from the beginning.
Yeah, as I mentioned, like the focus is just the geometry, but we want to make sure that you're actually thinking about it from a design perspective, these other concerns, although you don't have to, we're not expecting a rigorous analysis of every criteria.
Yeah, for example, sound, how do we test sound?
Yeah, we just want you to be thinking, that's just a clue to be thinking about. That is the criteria of envelope, so consider that. For some people that may become more of a driving force for their design, for others maybe not, but it should be a consideration. Yeah. Other questions?
And also, I have one more, sorry, this is the last one. You said the areas of interest for specific groups. So
Yeah.
you will give us assignments next time?
Yeah, so two things which you haven't received yet. One is going to be a rubric of how we're going to be evaluating the assignment. And so that'll be a more detailed description of exactly kind of what we're talking about now, what's expected with regard to each of the different criteria. So hopefully that helps. That should be coming later today sometime. And then the second will be we're going to look for panel representation for different parts of the surfaces, like corner conditions and areas of different curvature. So we're going to have like 3 or 4 different parts of the surface highlighted. And then in your presentation, you will be showing a typical panel from each of those areas. So that's also coming either later today or tomorrow in terms of those 2 documents. And they'll be in the assignment folder. Yeah. All right. Anything else? All right. Well, yeah.
I have a question for the technical.
Okay, yeah, sure. I can spend a few minutes just following up and getting any Revit or Dynamo Works results.
Great. All right. Well, hope to see you guys tonight, if not on Wednesday.
Of course. Yeah. So I'm saying this class for no credit. So you turn off the GoToMeeting. Do you need to do anything in recording?
We just need to stop it.
Yeah, sorry. I'm not taking this class for credit. Okay. So I'm just going to drop the class, but we're still going to take
Yeah, I can add you as a guest.
Okay.
Yeah. Okay, so you're not.